What if I told you that a single virus, just one microscopic particle too small to see with your eyes, could start a chain reaction that involves almost every major system in your body? It sounds impossible. After all, how much damage can one tiny invader really cause? But the moment a virus enters your body, an invisible battle begins. Your immune system launches a massive defense operation. Cells start sending emergency signals, and the virus begins searching for a way to take control. The surprising part is that you may not feel anything at first. While you go about your day normally, a microscopic war is already unfolding inside you. The journey usually begins when a virus enters through your nose, mouth, eyes, or a small break in your skin. As soon as it gets inside, it starts looking for a suitable cell to infect. Unlike bacteria, viruses cannot reproduce on their own. They need to hijack your cells and turn them into virus-making factories. Once the virus finds a target cell, it attaches itself like a key fitting into a lock and slips inside. After entering the cell, the virus releases its genetic material. This could be DNA or RNA, depending on the type of virus. The infected cell is tricked into following the virus's instructions. Instead of carrying out its normal duties, it begins producing viral components. New virus particles start assembling inside the cell, multiplying rapidly. One virus can become dozens, then hundreds, and eventually thousands. At this stage, your body is not completely unaware. Special cells known as sentinels constantly patrol your tissues looking for danger. When they detect viral activity, they release chemical alarm signals called cytokines. These signals spread through nearby tissues and alert other immune cells that an invasion is underway. As more immune cells arrive, inflammation begins. Tiny blood vessels widen, allowing defensive cells to reach the affected area more quickly. This response helps contain the infection, but it can also produce some of the symptoms people experience during illness. You may begin to feel tired, develop a sore throat, or notice mild discomfort as your immune system ramps up its defenses. Meanwhile, infected cells may sacrifice themselves to stop the virus from spreading further. Some cells activate self-destruct programs, essentially choosing death to protect the rest of the body. It's a remarkable act of biological teamwork happening millions of times without your awareness. If the virus continues multiplying, the immune response becomes stronger. White blood cells called macrophages start consuming infected cells and debris. Natural killer cells search for infected cells and destroy them before they can release more viruses. This helps slow the infection and prevents it from gaining complete control. Soon, the adaptive immune system joins the fight. Unlike the body's general defenses, this system learns exactly what the virus looks like. Specialized cells begin creating antibodies, tiny proteins designed specifically to recognize and attach to the invading virus. These antibodies act like tracking devices, making it easier for immune cells to find and eliminate the threat. At the same time, T cells launch targeted attacks against infected cells. They identify which cells have been compromised and destroy them with remarkable precision. This coordinated response often determines whether the infection remains mild or becomes more severe. As the battle continues, your brain may become involved. Cytokines can influence brain activity, leading to symptoms such as fatigue, sleepiness, reduced appetite, and the desire to rest. Although these symptoms feel unpleasant, they are actually part of the body's strategy to conserve energy for immune defense. If your immune system gains the upper hand, viral numbers begin to decline. Fewer cells become infected, damaged tissues start repairing themselves, and inflammation gradually decreases. Symptoms begin fading as the body restores normal function. But the story doesn't end there. Some immune cells become memory cells. These cells remember the virus for months, years, or even decades. If the same virus tries to invade again, your immune system can respond much faster and more effectively. This biological memory is one reason many infections become less dangerous after previous exposure or vaccination. In some cases, viruses can evade defenses, mutate, or overwhelm the immune system, leading to more serious illness. However, for many common viral infections, the body's defense network eventually wins. What started as a single microscopic invader ends with a highly coordinated response involving trillions of cells working together to protect you. The next time you hear someone mention a virus, remember that even one viral particle can trigger an extraordinary chain of events inside your body. From the first moment of entry to the creation of long-lasting immune memory, your body is constantly fighting to keep you alive and healthy.
Follow us for more health just like this, and stay informed.